Okay, it's 17.3, complex numbers. We're going to learn something called DeMoivre's theorem. And basically, it just allows us to do stuff with numbers in Cis form. So let's just make sure you really understand what Cis form is before I launch into trying to explain what that means. All right, so let's do an example of Cis form. So do you remember making 1 plus I into a picture, and you say over 1 and up 1, and this was the x-axis and this was the y, but not just the y, it was the y what? Y axis. Okay, then that spot right there, that was 1 comma, no, it's not really, it's 1 plus I, but we put it in that spot to represent 1 in the real direction, and this is the imaginary side, and it's got 1 in the imaginary direction. So 1 this way and 1 that way, and there. Then how did we do Cis form for it? Cis form, if I said like 5 cis pi over 6, what that means is the r is 5 and the theta is pi over 6. So it's kind of mixing together this complex with polar. So how far is this? Well, if this is 1 and this is 1, that's square root of 1 squared and 1 squared, which is 2. And I know that triangle. That one's got a 45 right here. And so this, in Cis form, would you please write what it was in Cis form? You know it's r. You know it's theta. Write it like this. We always use radians when we're writing them in Cis form. It's not 5 cis pi over 6. I'm saying it's like that. Okay, and our r is square root of 2. And then it's cis. And then it's the angle goes there. What angle is it? 45. And that's also known as pi over 4. Raise your hand if you had that one right. Okay, awesome. Give me another, this is make sure you really got this. It's going to be totally different. Would you please tell me what 1 minus I looks like? I'd start with rectangular, complex rectangular, and then I would change it to Cis form by making it polar. Let's figure out what that looks like as a cis. Like 3 cis negative pi over 6. Figure out what it is. Okay, so first of all, 1 negative 1 means go over this way 1 and then down 1, and there's a dot right there. And that represents this complex point in the x, y, I, which is that polar? Trying to make sure you keep these straight because they're going to be asking you, put it in polar, and if you're like, is that polar? I don't even know if that is polar. You can tell if it's polar if you have an r and a theta. Do we have an r and a theta? No. So we could figure out an r and a theta. That'll be polar. So I can make a little triangle that goes up to this point, but isn't the point, but it like helps me find it. And then I can say this must be square root of 2 again. And then I must be, oh, it's the same exact angle at 45, and therefore pi over 4, except it's negative. Okay, so then if I had 1, oh, that's wrong. Sorry. Cis. For Cis form, I need the r first, square root of 2, cis, and then I need the angle negative pi over 4. That would have been Cis form. Raise your hand if you had that right. Okay, awesome. One more thing I need to talk about right now, and that is what this CIS means. Yes? Nope. You, just like an inverse trig, anything in this area we use the negative angles for, just like an inverse trig. So we would not want to use 7 pi over 4. Okay, so my next thing I need to explain to you is what that actually is an abbreviation for. CIS form stands for, I'm going to stretch this out now, square root of 2 times cosine plus I sine of the angle. And what is the angle in this case? Negative pi over 4. Now, that looks really complicated. Let's investigate it a little further, because I hope you would like to know what it means. If you don't care what it means, you can actually get by with just saying cis, but it also opens up an easier way to do these problems sometimes. Let me show you why. Remember how before we could do those problems without knowing that x was r cosine theta and y was r sine theta? We could do it with just the triangles. You know what I mean? It's kind of like that. But behind it, all of a sudden, if you realize this, you got more power to be able to solve other problems. So same thing here. You can do this stuff by just drawing the triangles and figuring out your cis form from that. But watch what happens when I actually work this all out. What is cosine of negative pi over 4? Remember, cis stood for cosine I sine. C-I-S. Okay, what is cosine of negative pi over 4? Well, here's my little triangle. It's all drawn for me. What is cosine of that central angle, which is always the one we care about right there? Cosine is adjacent over hypotenuse. That's 1 over root 2. So I go square root of 2 times 1 over root 2. Okay. Plus, what is I times sine of this little triangle? Sine is opposite of hypotenuse, negative 1 over root 2. And do you see what's going to happen when I multiply this out? Do you get how those square root of 2's are going to cancel as I multiply this in? And I'll have 1. Do you see how when I multiply it over there, the square root of cancels? The square root of 2 on the bottom cancels, and I have minus 1i, which is I. I got it back again. It's the thing I started with. That's another way to get to 1 minus I. When would you ever use that? Okay, for example, let's say we said square root of 2 cis, just cosine I sine. Let's say you were given this question. Slightly different than what we just did, very similar. And you were asked to make it into its rectangular form. Because remember, this is just a place. It's a place, and I just told it to you in polar. Well, you could multiply it out and go 2 times cosine plus I sine, and then you put the angles in the logical places. Cosine doesn't make any sense unless we have an angle. And sine, would you please multiply that all the way out? Because you know sine and cosine of pi over 4. If you have to, go make your little tiny classic right triangle that has pi over 4's in it, also known as 45's, by the way. And I screwed up at the square root of 2 in the front. Sorry. There, square root of 2. Have a good day. Okay, so what does cis mean again? Cosine I sine. And I actually, to help kids remember this, just put this little plus in here. There's a tiny plus buried in the cis. Cosine plus I sine. Because it's easy to forget that. It's as easy to think it's all a big multiply, but it's not. So then, what is cosine of pi over 4? I'm going to draw my little picture. My classic 45, 45, 90 triangle. 1, 1, root 2. And then I go cosine of this, adjacent over hypotenuse, 1 over root 2. And I have a root 2 out in front. And that's going to cancel really nice. And then I times sine of this. Sine is opposite over hypotenuse. 1 over root 2. And it's just like that last one, except without the negative. So then I go, this times this makes 1. And this times this makes 1i, or I. You could say 1i, and I'd be fine with that. Raise your hand if you were able to get to that. Okay, good. So that's what cis really stands for, is cosine I sine. I still like the pictures because I think it's intriguing that you can do half of pre-calc and calculus by just drawing triangles. Okay, that's a pretty bold statement, but in calculus, when you do your trig, I know they're going to tell you, hey, just draw the triangles. Now, if you've got the unit circle memorized, that's awesome. That does help, and it is a little faster. But just the fact you can keep drawing triangles all over the place. Even in circle trig, we draw triangles. So if you get that part down, you know, like here, I just solved this problem. I drew another triangle. Anyway. All right, so now you know a little bit better what cis is. So let's say I had to take this, 1 plus I, and this, 1 minus I, and I wanted to divide them. Remember doing this before? You had to do that conjugate thing? Well, there's a new sheriff in town. There's a new way to do these things. And it's way easier if you have cis form. We just did these two. Does anybody have a short-term memory? What was this in cis form? It had a root 2 in it. Yes? Remember? Root 2 cis pi over 4. And this guy on the bottom? Yep. I think the easiest way is to just draw the little pictures to find those cis. But that's why I want to review how to find cis at the beginning of the hour. So now we got them in cis form. Now, there's a really easy way to multiply them, divide them, like this is a divide problem, or put them to a power. And this is where DeMoivre's comes in. All right, we're going to just stop for a second and go to this slide. It's the second slide. It's got all this really fancy stuff written out that I don't need you to go rewrite out, but we're going to look over. This would be like what the textbook would say. And man, this is getting deep. Like, give that to a second grader and they're going to never want to do math again. It's like, what does it even mean? It's so complicated. Okay, but it's really not that bad when I explain it to you. Okay, we're going to go up here. The product rule, Z and W are just getting multiplied together. So those are two, what kind of numbers? The whole title of the unit. Two complex numbers. Z and W getting multiplied. And it's telling you how to do it as long as they are in polar form, as in cis form. If they're in cis form, then you just have to take the number from the front and the other number from the front, and do you see what we're going to do to them? You're going to multiply them. And it's a big surprise. If you are putting a product, this is a multiply, there's going to be multiply involved. We are going to multiply the numbers that are in front. Then it's cis. That's easy. I just write CIS. And then what do we do to their two angles? Say it. Add them. This is plus. Okay. So we multiply the numbers in front and then we add the angles. So for an example, let's say we had 2 cis pi over 6, and we had that being multiplied by 4 cis pi over 2. Remember, if it's multiply, you multiply these guys. There's got to be multiply involved, right? So that's going to make an answer of 8 cis. And then what do you do to the angles again? Add them. Multiply and add going together again. All right, so if I want to add these, it'd be pretty nice if they were both in 6. So I'm going to say pi over 6 plus 3 pi over 6. Do you agree that that would be the same as pi over 2, or 1/2 pi is the same as 3 pi over 6, right? So final answer, 8 cis and 3 plus 4 pi over 6. I really do want you to simplify whenever you can, like simple, like 4/6 is the same as 2 pi, right? Over 3. There you go. What happened? We took two numbers in cis form. We multiplied them. And to do that, we took the number in front, which was the r's. Remember, those are the r's, not the thetas. And then we multiplied the numbers in the front, and then we added the angles, the thetas. Thetas just get added. All right. Just think logically, like, okay, math is fairly, like, it's predictable a lot of times. Sometimes it's counterintuitive, but if I was going to divide these two, what do you think I do to the r's? Sorry, the r's, the front numbers, these guys. What would your gut be that we should probably do? Divide them, right? I mean, we just multiplied last time, and when we multiplied them, so let's try to divide them. 2/4, and then I got cis, and then just think, like, it's not super complicated. What do you think we do to the angles? Subtract them. So we use pi over 6 minus, and again, make them common denominator. If you want to see how that worked, I'm timesing by 3 on top and bottom. That makes 3 pi over 6. 1 pi over 6 minus 3 pi over 6 makes, final answer, 1/4. I'm going to simplify this. 1/4 cis, and then negative 2 pi. I'm going to make sure I'm doing that right. Negative 2 pi over 6, which reduces. Final answer, 1/4 cis, negative pi over 3. Uh-oh. 2/4 is 1/2. Thank you. Thank you. Keeps wanting to be 1/4. Really wants to be 1/4. There we go. Catch. Okay. So that's multiplying them and dividing them. Well, let's actually verify that we just did that right. Let's see the quotient rule here. We just guessed what to do. Let's make sure it was right. We took the two lead numbers, or sorry, the two numbers in complex, and they probably should be in cis form. They don't have to be, actually, but to use this formula, you're going to want to have them in cis form. And I divide the two lead numbers, the r's, and then I subtract the angles. And it was, provided that you can't have a 0 in front of any of the, in fact, just that one. That's kind of weird. But when you had a 0 radius, that would be a pretty unusual situation anyways, right? A 0r. All right. So last but not least, this one is the one that says DeMoivre's theorem right next to it. And that's the one for powers. So that goes like this. You're faced with a cis. 2 cis pi over 6. Nice simple one. And I say, I want to put that to the third power. Could I break that up into multiply by itself and then multiply by itself again? Isn't that what to the third means? Yep. But DeMoivre figured out this really cool, quick formula for figuring these out. You just have to drop this, and I'm gonna say this in a funny way, but it's gonna help. It really does help you remember how to make this work right. DeMoivre is about DeMoivre of the exponent. Ready? That 3 there goes here and there. Not here. It seems like it should be. Nope. It's there. And now it's not to the third anymore. That's all there is to it. Piece of cake. So you put it to the third. It's 2 to the third, which is what? 8. Cis. And then 3 pi over 6. I say to reduce those things, so therefore what? Pi over 2. There's my answer. And it seems so foreign, like, what is this thing? It's a complex number. Is it 8 plus pi? No. It has an I And it has, it's something like 4 plus 3i. Exactly what is it? I just showed you a new way you could do it by remembering what these mean. I'm going to throw in a little helper thing. Little plus in there. Remember what that means again? Cosine plus I sine. So then it's 8 times cosine of pi over 2. Do you think you could find that somehow? It's a quadrantal, but you could find it, right? Plus I times the sine of pi over 2. Again, it's a quadrantal. Once you know where it is, it's really no big deal. Would you please finish that off and do it with the cis thing? You could have done it with the triangle. I still believe in triangles. If you want to do it that way, that's fine. Figure out where this thing is in space. We are going to graph it. And it's just a representation of it because really, it's got imaginary stuff in it. We can represent how it looks, but it can't really look like anything because it's imaginary. I'm trying to tell you the fine points here. It'd be easier for me to just say graph it, but just trying to remind you, it's an imaginary thing. Some of it's real. All right, cosine of pi over 2. In case you haven't done this part yet, pi over 2 is right here. And then I always do this by using that. What point is this on the unit circle? 0, 1. And therefore, I know cosine of it is the x. So that's 0. Ooh, cool. That's just 0. That makes it easy. And then sine of it is the y, which is 1, 1. So 8 times 0 is still 0, plus 8 times that would make, that has just turned into 1, so that's 8 times 1i, which is 8i. There's your spot. Cool. You've just learned to add, subtract. Oh, yeah, we already did those before. Add and subtract complex numbers. Now you can multiply and divide them in polar form. And the most cool thing of all, DeMoivre, which is when you do it, put it to a power. So let's do one last one to a power. 3 cosine pi over 6 to the second. Would you please square that? Use DeMoivre. And the thing that's cool about squaring, and you can use DeMoivre on it, is that it actually means multiplied by itself. And that means you can check and see if the answer comes out different in DeMoivre than it would if you actually just had a multiply problem. 3 cosine of pi over 6 times 3 cosine of pi over 6. You should know how to multiply them. And you should know how to use the DeMoivre thing. So would you just check and make sure? If you got both of these down, you should be able to say, I know how about to do the DeMoivre, or you DeMoivre over the exponent. And I also know how to multiply them, and they should come out the same, shouldn't they? All right, check and see that they really do. I'm going to pause for a second. Okay. It's all about DeMoivre of the exponent. Notice you don't square this one. You times it by 2. And then it's not squared anymore. That, I think, is pretty easy. 9 cosine of 2 6, which would be 1/3, and so that's pi over 3. Boom. Done. See how fast DeMoivre is? All right. Yes? Yeah, my goodness. I almost feel like re-recording the video. These are supposed to be Cis Form. My brain just wrote cosine. I don't know why. Yeah, I think did you guys do Cis Form? I'm assuming you did. Okay, yeah, I can't believe the first person to say anything. All right, yeah, sorry. Those are all supposed to be in Cis Form. Oops. Okay, and then this kind, you multiply the lead numbers. 3 times 3 is 9. And then you're supposed to add these two. What is 1/6 plus 1/6, it's 2/6 pi, which of course simplifies down to pi over 3. And they got the same answers. Yay. All right, that covers multiplying and putting to a power. One last one where we would divide them. 4 cis pi over 3 divided by 2 cis pi. Yeah, you can have issues with denominators and stuff, but figure it out. You're dividing two things that are in cis form. At least I didn't try to do it with cosine this time. Ugh. Pausing. Okay, these aren't super hard. You divide those two just like you'd kind of expect you would. 4 divided by 2 is 2. Cis, and then what do you do to these two angles? Subtract them. So pi over 3 minus, and then if I was going to put it in pi over 3s, this would be 3 pi over 3, right? And then what's 1 pi over 3 minus 3 pi over 3? It's negative 2 pi over 3. 2 cis negative 2 pi over 3. If I said that's a place, just in your head quick, picture where that would be. It's a dot. Can you picture where on the x, y, I axis that would be? You know where negative 2 pi over 3 is? You know what radius of 2 is? All right. Now, I'm just realizing there's a chance that this might not actually work because we are in no man's land. But I am going to investigate that for you for the future and try to figure out that answer. So, we're not going to give you one that would do that to you, but remember how we usually only go to here? I am going to check into that and get back to you on that one. So, anyway, we did the process right. Whether or not we just found something that's actually no solution is by question. But I'll tell you that tomorrow. Okay, so let's look at the homework for tonight. Don't worry, I'm not going to try to trick you on that. There's a whole lot of pages in this file. I want to find the first one that says homework day 4. That's it. This is the 4th day of the overall unit. Okay. So, here's w to the 3rd. Well, what is w? W is up here. So it's that to the 3rd. But wait, you never did them like that, Mr. Server. You're right. So what do you have to do first? Change it into cis form. All right, I'll help you with that. So let's get this changed into cis form. So first thing I would do is draw it and figure out where I am. Now, that length, I don't know exactly how long 3 root 2 is. It doesn't really matter. I'm going to label it as 3 root 2. Okay, but it's this way because it's positive. Next, it's negative 3 root 2 going down like that. 3 root 2, another 3 root 2. And then I realize, oh, those are the same. Do you get that that's just like the 1, 1 root 2 triangle? And therefore, I know the angle. If the two sides are the same. All right, so now that length, not that bad if you remember my pattern. You go square root of, and then you got to square this one, think it through, times by itself, 3 root 2 times 3 root 2. The 3 and the 3 can go together, would be 9. The root 2 and the root 2 to go together, and that would make root 4, which is really 2. 2 times 9, 18. That one's 18, and then this one squared is also 18, and then you add them. Square root of 36. Ooh, I know that one. 6. That side is 6. Now, you can do that with a squared plus b squared equals c squared, but I'm telling you, there's a reason I made up that little pattern. of you take the square root of and you square the other two. It just goes a lot faster. This one came out to 18. This one, when you square it, will come out to 18. This one comes out to the square root of 18 plus 18. All right, which is square root of 36, which is 6. All right, so now I've got cis form. That's the first thing I needed to know, was what is this thing really in cis? And it is 6 cis. And what was the angle again? This is negative what? What's the angle? You should recognize these are the same, and therefore that's like a 1, 1, root 2 triangle, and therefore it's 45, also known as pi over 4. Don't forget it's negative pi over 4. There. Now I can use DeMoivre's because it's putting it to the third power. It's all about DeMoivre of the exponent for DeMoivre. And there we go. And there we go. And 6 to the third is not one that I just keep memorized off the top of my head. Anybody figured it out yet? 6 times 6 is 36. 36 times 6. What? 216. Sounds believable. Cis, and then I put the 3 there, and it's not here anymore, so 3 pi over 4. The actual DeMoivre part's easy. It's the getting it in cis form that's tough. Now that we've got it in cis form, anytime they ask you for W, we already know W in cis form. It's right here, 6 cis pi over 4. Negative pi over 4, sorry. 6 cis negative pi over 4. So to answer the rest of these things, that one, z to the 5th, well, first of all, I better figure out z, this guy, in cis form. A little bit of a pain in the butt. All right, so I'm going to have you skip one of these. Let's skip 47. I'd like you to have 45, 46, 48. That'll cover multiplying, putting to a power, and dividing. Those are the 3 major things you can do with cis form now. And I want you to not forget that they could write the problem like this. And it's the same basic problem. It's just you're getting a weirder way to start. You still need cis form. You could get cis form for that and then DeMoivre it. So it's just written different. I don't want you to blank out on the test when they're like, but you never did them like that. So we'll do these 2. All right. Now, I don't need to go further with this because this is just the same thing over and over again. So those 2 pages, this one, 45, 46, and 48, and those 2. Most of your work today is just putting things that are icky into cis form. DeMoivre's easy. Okay, that's all I got for you for today.